Sairam. Having seen certain electrochemical methods in this metallurgical processes, now let us see one method which is involving oxidation and reduction. Just to revise, what is oxidation, what is reduction? Oxidation can be told as adding of oxygen and removal of hydrogen, but here whenever we talk regarding these processes, we will rather talk in terms of addition of electrons or removal of electrons. Now, this method which is there is basically employed for extraction of non-metals. If you remember the chapter name, it did not say isolation of metals, though we happen to study only about metals till now. It did not say just about isolation of metals, it said about isolation of elements. So, here the element that we are going to obtain is chlorine. As you know, chlorine happens to be part of group 17 in the periodic table. It is generally obtained in gaseous form, but how do we extract this chlorine? This is obtained very easily from a salt which is sodium chloride. Now, where do we obtain this salt in general? It is nothing but our common salt which we happen to use on a day-to-day basis. This sodium chloride in large quantities can be obtained in seas and oceans. So, what is done here is a same electrochemical process is employed where an aqueous solution of sodium chloride is made. An aqueous solution essentially indicates mixing of NaCl and H2O. So, what are the byproducts in this system? The byproducts happen to be NaOH, which is in the form of electrolyte. The main compound that we want here is chlorine gas, and then along with that is hydrogen gas. Just to talk about balancing of these reactions, if we can see this reaction now, we have one chlorine on the left hand side, two chlorine atoms on the right hand side. So, for this balancing, let me first take it up as 2. So, what has happened in this process here? We see that there is a disturbance that has been made with respect to sodium. There are 2 sodium atoms on the left side, 1 sodium atom on the right side. So, now I need to write it as 2 NaOH. Count the number of hydrogens now. This is 2 plus 2 on the right hand side. To have it similar on the left, I have to take it as 2 H2O and then 2 oxygens on the left, 2 oxygens that I can see on the right. So, this is the reaction that actually happens. Now, it is seen that this reaction actually has a free energy of plus 422 kilojoule. Now, what do we mean by this? Delta G, if it is positive, it indicates that it is a non-spontaneous reaction, which means that it needs certain external force. What is that external force? The EMF that is generated here is given by minus 2.2 volts. What is the relationship between delta G and EMF? We know it to be delta G is equal to minus NF E naught. So, by this relation, once we know the delta G value, we can get the EMF as minus 2.2 volts, which means that if I have to make this reaction happen, the electricity offered should be more than 2.2 volts, so that it can negate the energy which is present inside this. So, like this, from this reaction, we tend to get this chlorine gas for our elemental processes. Remember that NaCl in earlier classes you have studied this to be as brine solution. Now, this was a case when we had the aqueous solution of NaCl. What about if we use a molten sodium chloride solution? Now, molten indicates a state between a solid and liquid. In the case of molten sodium chloride, whenever we undertake electrolysis, this is only in the presence of electrolysis, we get sodium metal and chlorine gas. Once again, for balancing of reaction, this is the representation. Once this chlorine gas is obtained, we have to see here that in this case, sodium hydroxide was electrolyte. Chlorine gas being negative, it should go to the positive electrode, hydrogen gas will go to the negative electrode, whereas here sodium metal is connected on one side and chlorine gas is connected on the other side. This is one such example of obtaining a chlorine gas. Similarly, this method can be employed for low reactive native metals like gold, silver or platinum. So what is the process employed there? We actually happen to see that in an earlier concentration process. Do you remember that? Well, let me explain the process and maybe then you can think over it. Supposing if I have gold metal, remember the similar example we had used it for silver metal in the earlier case. This gold metal I am going to treat it with sodium cyanide in the presence of water and oxygen gas. These are the reactants that are seen. So what are the products that we obtain here is we get a complex compound of sodium which is given by NaAuCN twice plus NaOH. Balancing of these systems now will be an important factor here. This is a compound where we take it as 4 Na and 4 NaOH. This is taken as 8 NaCN, 4 gold atoms which are being considered here, and for the balancing of the water and the oxygen part, remember that there are 4 hydrogens on the left side, so this has to be 2H2O, which will automatically suffice the number of oxygen atoms on either sides. This side it is in total 4, whereas this side it is 4. This complex compound is taken into the next step where the name of this complex compound is sodium aurum cyanide. This complex compound gets treated with zinc to obtain Na2ZnCN twice plus Eu. So what is the overall system that we tend to obtain here? So in this case, whenever we take over these type of reactions, this is twice. For balancing this, since this becomes 4, the cyanide form which is obtained here is rather as CN4. Here the zinc metal is also present. That zinc metal being more reactive in nature displaces gold metal in this case. So what has happened in this entire system here? Always remember that oxidation state of any element will be 0. What about the oxidation state of gold here? Remember that sodium is +1, Cn is -1, but we have 2 Cn atoms, so that is why this is -2. If this compound has to be stable, then it has to be this gold part which is there should also be +1, so that +2 and -2 will make this a stable compound. Any stable compound should have its charge equal to 0. Since it is the same compound that I have taken, so let me once again write that -2. What has happened in this case now? Since we have got this gold outside and now it is in elemental form, the valency of this compound is 0. What has happened here is that 0 to +1 state indicates loss of electrons, +1 state to 0 indicates gain of electrons. This is how we realize that there is an oxidation and reduction process that is happening. In this overall condition, what we see here is that any impurities associated with gold will get dissolved in this compound, and further when a reactive zinc metal reacts, all the impurities will go away with the complex, and finally you will be getting a very pure gold metal. This is all that we have for oxidation and reduction. Thank you. Sai Ram.